Winter 1944. Somewhere on the Eastern Front, across thousands of miles of frozen battlefield, a machine is approaching through the darkness. It has already survived artillery barges, anti-tank guns, mud, snow, and some of the largest battles in human history. Tonight, we are going inside one of the most influential tanks ever built. Before we see the armor, before we see the gun, we must first enter the battlefield where legends were made. At first glance, it looks simple. Rough steel, sloped armor, wide tracks. But hidden beneath these plates is a machine designed for one purpose: surviving war. The T-34-85 was not built to be beautiful. It was built to move, fight, and keep moving when everything around it was collapsing. What made this tank different was not what enemies could see from the outside. The true story begins beneath the armor. Hidden inside are 4 men, a powerful diesel engine, dozens of mechanical systems, and a design philosophy that would influence armored warfare for decades. Every battle depended on 4 crewmen working inside this incredibly confined space. The driver controlled movement, the gunner aimed, the loader fed ammunition into the gun, the commander coordinated everything. In combat, every second mattered. A delay of only moments could mean destruction. Behind the crews is the true heart of the T-34-85, the V-2 diesel engine. Unlike many tanks of the era, this engine delivered a combination of reliability, power, and fuel efficiency that helped transform battlefield mobility. Every movement of the tank begins here. Inside each cylinder, controlled explosions generate enormous force. That force turns a crankshaft. The crankshaft transfers power into the drivetrain. In only fractions of a second, chemical energy becomes mechanical motion, pushing more than 30 tons of armored steel across the battlefield. The engine alone cannot move the tank. Power must travel through a network of gears and shafts. These components multiply torque, allowing the vehicle to climb steep terrain, cross trenches, and continue moving even under extreme battlefield conditions. The tracks are one of the tank's most important advantages. Their wide design spreads weight across a larger area, helping the vehicle move through mud, snow, and rough ground where other vehicles often became trapped. Mobility was survival. A tank that cannot move is simply a target. The T-34-85 was designed to maintain momentum across some of the harshest environments on Earth. Whether crossing frozen landscapes or shattered battlefields, mobility allowed it to appear where enemies least expected. To truly understand the T-34-85, we must take it apart. Every plate of armor, every gear, every spring, every shell rack, every mechanical component. What appears from the outside to be a simple machine is actually a highly organized system containing thousands of individual parts working together toward a single objective: victory. Every component inside the T-34-85 exists for a specific purpose. Unlike many complex modern vehicles, this tank was engineered with simplicity in mind. Simplicity meant easier production. Simplicity meant easier repairs. Most importantly, simplicity meant more tanks reaching the battlefield faster. The turret is the tank's primary weapon platform. To engage targets in any direction, the entire turret must rotate smoothly and reliably. Hidden beneath the crew is a system of gears, bearings, and mechanical controls that allows the gun to swing toward approaching threats. Inside the turret, space is extremely limited. Every piece of equipment must fit within a confined area while remaining accessible during combat. The crew must operate efficiently despite constant noise, vibration, heat, and incoming enemy fire. The most significant upgrade of the T-34-85 was its powerful 85mm gun. This weapon dramatically improved the tank's ability to engage enemy armor at greater distances and increased its effectiveness against heavily protected targets. The barrel is more than a simple metal tube. Precision-machined rifling grooves spin the projectile as it travels forward. This stabilizes the shell during flight and greatly improves accuracy over long distances. Every shot begins with the loader. The shell must be lifted, positioned, and inserted into the breech as quickly as possible. During battle, speed can determine whether the crew fires first or becomes a target. Once aligned correctly, the shell slides into the breech. The process appears simple, but every movement must be performed accurately under intense battlefield pressure. Mistakes can slow the firing cycle and reduce combat effectiveness. After loading, the breech seals the rear of the gun. This critical mechanism must withstand enormous pressures generated during firing. Without a secure lock, the weapon would be unable to operate safely. With the weapon loaded, the gunner searches for a target. Through smoke, dust, and confusion, enemy armor appears in the distance. The next few seconds will determine the outcome of the engagement. Everything is now ready. The shell is loaded. The breech is locked. The target is identified. Deep inside the cannon, a chain of mechanical events is about to unleash one of the most powerful forces available to armored crews of the Second World War. The firing sequence begins in less than a fraction of a second. The firing pin strikes the primer at the rear of the shell. To the crew, it feels instantaneous. Inside the weapon, however, a remarkable chain reaction has just begun. The primer ignites the propellant. Within milliseconds, rapidly expanding gases generate tremendous pressure. This pressure has only one escape path, pushing the projectile forward through the barrel. As pressure increases, the projectile accelerates violently. The rifling inside the barrel grips the shell and forces it to spin. This stabilizing rotation helps maintain accuracy during flight. The projectile exits the barrel at tremendous speed. A massive muzzle blast follows. For a brief moment, fire, smoke, and pressure erupt into surrounding air with incredible force. Now traveling at high velocity, the shell races toward its target. Distance that seems vast to human eyes disappears in moments. The projectile remains stable, guided by the spin imparted by the barrel. Ahead lies an enemy armored vehicle. Protected by steel and designed for survival, it represents the ultimate test of the T-34-85's firepower. Upon impact, enormous kinetic energy concentrates into a tiny area. Steel begins to deform. Temperatures rise instantly. The armor and projectile enter a violent contest of strength. If the projectile successfully penetrates, fragments of armor and shell material are thrown throughout the interior. These fragments can damage equipment, ignite ammunition, and threaten the crew inside. Inside the vehicle, the consequences are devastating. Mechanical systems fail. Visibility disappears. Crew effectiveness drops instantly. A single successful penetration can determine the outcome of an entire engagement. This combination of mobility, protection, and firepower helped make the T-34-85 one of the most successful tanks of the Second World War. But battlefield performance alone does not explain its impact. To understand that, we must travel to the factories that built them by the thousands. Every T-34-85 that reached the battlefield began its life far from combat. Behind every tank stood an enormous industrial network of factories, railways, workers, engineers, and resources. The real secret weapon of the Soviet Union was not a single machine, but the ability to build thousands of them. The process begins with steel. Vast quantities of raw materials arrive daily. Ore is refined, melted, and transformed into the armor that will protect crews on the battlefield. Every armor plate begins as liquid metal heated to extraordinary temperatures. Armor plates must be carefully shaped and prepared. Thickness alone is not enough. Engineers must balance protection, weight, mobility, and manufacturing speed. Every decision affects battlefield performance. One of the tank's greatest innovations was its sloped armor design. Instead of relying only on thickness, angled armor increases effective protection while encouraging enemy shells to glance away rather than penetrate. The turret begins as a giant steel casting. Molten metal is poured into specially designed molds where it cools into one of the most recognizable shapes of the Second World War. The 85mm gun barrel must endure extreme pressures. Forging and machining transform raw steel into a precision weapon capable of surviving thousands of firing cycles. Inside the barrel, precision rifling is machined into the steel. These grooves play a critical role in stabilizing projectiles during flight and improving combat accuracy. At the same time, engines are assembled in separate production facilities. Hundreds of individual parts must come together perfectly. Reliability is essential because mechanical failure on the battlefield can be fatal. As components arrive from across the Soviet Union, final assembly begins. Hulls receive engines. Turrets are installed. Tracks are attached. One by one, new tanks emerge ready for combat service. The true strength of the T-34-85 was not simply its design. It was the ability to produce it in overwhelming numbers. Thousands of tanks roll from Soviet factories, creating an armored force capable of replacing losses and sustaining relentless battlefield pressure. By 1945, the war in Europe was reaching its final chapter. Soviet forces advanced toward Berlin, the heart of Nazi Germany. Ahead lay one of the most heavily defended cities in history. The T-34-85 would play a major role in the final assault. Urban combat is very different from open battlefield warfare. Long-range engagements disappear. Every intersection becomes a potential ambush. Every ruined building may conceal anti-tank weapons. Tank crews move cautiously through the city. Infantry and armor must work together. A tank alone is vulnerable. Infantry alone lacks protection. Success depends on coordination between both. Inside the tank, the crew experiences a completely different battlefield. Visibility is limited. Communication is critical. Every crew member must focus entirely on their responsibilities. The greatest threat in urban warfare often comes from hidden positions. Anti-tank weapons can strike from windows, basements, rooftops, or narrow side streets with little warning. Suddenly, the tank comes under fire. Enemy projectiles strike the armor. In this moment, the effectiveness of the vehicle's protection becomes a difference between survival and destruction. The T-34 sloped armor was revolutionary. By angling the armor plates, engineers increased effective protection without dramatically increasing weight. Many enemy rounds lost energy or ricocheted away. Angle matters. Even powerful projectiles can fail if they strike armor at unfavorable angles. The T-34's design exploited this principle repeatedly throughout the war. When armor successfully protects a crew, the tank remains in the fight. Surviving a hit often means the difference between completing the mission and becoming another battlefield casualty. Despite fierce resistance, Soviet armored forces continued advancing, street by street, block by block. The T-34-85 became one of the symbols of the final campaign that would ultimately bring the war in Europe to an end. The Second World War produced many famous tanks. Some were more heavily armored. Some carried larger guns. Others featured advanced technology. Yet few matched the balance achieved by the T-34-85. Success in war is not determined by one feature alone. It is determined by the combination of protection, firepower, mobility, reliability, and production. Armor is often the first characteristic people examine. Thick armor can increase survivability, but excessive weight reduces mobility. Soviet engineers focused on creating effective protection while preserving speed and operational flexibility. The 85mm gun provided a major increase in combat capability. It gave Soviet crews the ability to engage enemy armor more effectively while remaining versatile against a wide range of battlefield targets. Mobility remained one of the tank's greatest strengths. Wide tracks, reliable suspension, and powerful diesel propulsion allowed it to operate in environments that challenged many other armored vehicles. The T-34-85 was not created in isolation. It represented the evolution of lessons learned through years of combat. Battlefield experience continually shaped improvements in design and performance. Behind every machine were real people. Drivers, gunners, loaders, and commanders faced extraordinary danger. The effectiveness of the tank depended not only on engineering, but also on the skill, courage, and endurance of its crews. When deployed in large numbers, the T-34-85 became a force capable of overwhelming defenses through speed, coordination, and sustained pressure. Quantity combined with capability created a powerful battlefield advantage. The story of the T-34-85 did not end in 1945. The tank continued serving in numerous countries around the world. Decades after the war, it remained active in military forces across multiple continents. As the decades passed, the T-34-85 became more than a military vehicle. It became a symbol of industrial achievement, wartime endurance, and one of the most influential armored designs ever produced. Many tanks have been forgotten by history. The T-34-85 remains remembered because it changed the course of armored warfare. Its influence can still be seen in military vehicle design today. Yet to truly understand its legacy, we must look one final time inside the machine itself. After exploring the battles, the factories, and the history, we return to the machine itself. At first glance, it appears simple. Yet hidden beneath its armor lies a carefully engineered system that transformed 20th century warfare. The T-34-85 is often remembered for individual strengths. Its armor, its gun, its mobility. But its true effectiveness came from how every system worked together as a complete fighting machine. Power begins in the diesel engine. It flows through shafts, gears, and transmissions before reaching the tracks. Every movement of the vehicle is a result of thousands of mechanical interactions happening simultaneously. Viewed from the inside, the tank resembles a living organism. Fuel acts as blood. The engine serves as its heart. The crew becomes its mind. Every component contributes to survival and combat effectiveness. Remove the armor, and the complexity becomes visible. What appears externally as a simple steel box is actually a densely packed network of systems designed to function under the harshest conditions imaginable. Beneath every armor plate lies a structural framework that holds the vehicle together. Strength is distributed throughout the hull, allowing to endure stress, vibration, impact, and continuous battlefield punishment. Thousands of individual components combine to form a single combat vehicle. Each bolt, bearing, spring, and gear plays a role. Remove enough pieces, and the entire machine ceases to function. Before becoming steel and machinery, the tank existed as an idea. Drawings became plans. Plans became prototypes. Prototypes became one of the most successful armored vehicles in history. The T-34-85 represents the culmination of years of battlefield lessons. Every modification reflects experience gained through combat. The result was a machine better suited to the realities of modern warfare. From concept to production, from battlefield to history, every stage of development contributed to the final machine. Piece by piece, the legend rebuilds itself before our eyes. Few military vehicles remain relevant decades after their creation. The T-34-85 continued serving around the world long after the war ended, becoming one of the most recognizable tanks ever built. Its influence extended far beyond the Soviet Union. Lessons learned from its design affected future armored vehicle development across multiple nations and generations. For the crews who operated it, the T-34-85 was more than machinery. It was protection. It was survival. It was their home during some of the most dangerous moments of the war. Every scratch in the armor, every dent, every repaired component tells a story. These machines witnessed some of the most significant events of the 20th century. Today, many survive as monuments and museum exhibits. Silent now, but still capable of telling a remarkable story through their design and history. Even after decades, the engineering remains impressive. The machine awakens once more, reminding us why it became one of the defining armored vehicles of its era. The story of the T-34-85 is ultimately a story of movement. Factories moving resources, armies moving across continents, crews moving toward uncertain futures. Its silhouette remains instantly recognizable around the world, a symbol of industrial power, battlefield endurance, and one of the most influential tank designs ever created. Wars eventually end. Machines eventually stop. But some designs leave a permanent mark on history. The T-34-85 is one of those rare machines. More than steel, more than machinery, more than a weapon. The T-34-85 became a legend. And now, having explored every major system inside and out, its story continues to inspire engineers, historians, and military enthusiasts around the world.